Going back to the moon sustainably means an enormous amount for science. We barely scratched the surface with Apollo. Discoveries are going to happen. I can't tell you what they're going to be. If I knew, they wouldn't be discoveries. Okay, but it's going to happen.
The national team is the kind of outstanding leadership, outstanding experience that I like to work with. Blue Origin itself brings innovation and modern thinking to the table. Lockheed Martin and Northrop Grumman and Draper all bring an extraordinary experience, not only from Apollo, but before Apollo into the present.
The combination of our heritage aerospace experience has created a team that I think really uniquely is able to meet the target that we have set for ourselves.
The HLS is a three-element architecture, our design. It consists of a crewed vehicle, an ascent element. This has the life support systems for the crew, all the displays, the controls, everything that the crew will do to interact and to land on the surface of the moon.
We're taking the Orion heritage and we're bringing that into the ascent element for the HLS program.
Familiarity with displays and controls plays a very important role in safe human spaceflight. The first thing is that it minimizes the amount of training you need to do. And the second thing is it makes operation of that system that much safer. They're using the same displays and controls technology that they used on Orion, and astronauts will be very familiar with that.
The next element in the architecture is the descent element. This is the landing element. This is what will actually have the thrusters, the legs, the systems that are going to be able to land those astronauts and give them that safe, comfortable touchdown on the surface of the moon. And so this is being built by Blue Origin and is based off of our Blue Moon lunar architecture.
You know, we've flown our New Shepard launch vehicle many times. It uses a pump-fed hydrogen engine that can throttle down to 20% power level. And the reason that we do that on New Shepard is the same reason that we're doing it on HLS. It's for the lander application. And the BE-7 has that same capability.
And then the final element in the three-element architecture is a transfer element built by Northrop Grumman.
Specifically, the transfer element avionics, its computers, its software, its sensor suites are derived directly from the Cygnus service module. It's particularly relevant as NASA uses that platform to routinely deliver cargo to the International Space Station, and it's the primary heritage source for the transfer element.
And so this transfer element is the element that takes the ascent element and the descent element from a deep space staging orbit down to an orbit around the moon where the descent element can then land the ascent element on the surface of the moon.
And of course, us at Draper, we've been working in guidance, navigation, and control and avionics solutions.
We've been developing the BE-7 for several years. Cygnus has been flying resupply missions to the space station. Orion has been in development for a long time. And so these technology demonstrations that have been developed in the context of those programs have already been underway.
So we're bringing a proven heritage and we're bringing it together as a national team, and that is the value and the real strength of this three-element team.
It's amazing to think that we're only 6 months into this program, and the number of tests we've done on this program compared to anything I've ever worked on before is just mind-boggling.
In the base period, we've conducted a campaign of 25 specific risk reduction tests in 8 technology areas that are fundamental to returning humans to the surface of the moon.
The BE-7 testing is happening out at the East Test area at Marshall, a place I know very well, and is excited to see when companies bring their work there, because Huntsville and Marshall in particular has a lot of capability in helping teams be successful.
We've run docking tests between our elements.
The rendezvous and proximity operations test went really well, where we're using actual LiDAR sensors to test out docking with already existing software.
We have another very critical set of demonstrations associated with our cryopropulsion module. In fact, we've just completed a thermal shock test using liquid nitrogen in a subscale version of one of the tanks that we will be flying on the transfer element.
We've taken our sensors and flown them on the New Shepard vehicle right to the edge of space. Being able to test those sensors as they execute a profile that's going to match the speeds and the altitudes that our actual sensors will see as we go down to the moon. We have a full-scale model of our vehicle down at the Johnson Space Center where the crew is able to come and interact with that vehicle, test it out, kick the tires. So one of these key tests that we just completed was an ascent from the lunar surface. And we used over 1 million lines of flight source code.
One of the most important things about the way we've chosen to do this is that we have a demonstration flight of our descent element 1 year before we actually send humans down to the surface. And that provides an enormous amount of risk reduction. We get to practice. We get to try everything out first without crew on board. And so we learn from that. We're going to learn an enormous amount.
So you could use it not only to take this stack down to low lunar orbit, but other things if you had another type of payload.
The division that we have between the elements also allows us to upgrade in modules. So not only will we get that first mission to the moon as soon as possible, but we will then be able to follow an upgrade path to continue to get to the moon in a sustainable manner. Our liquid oxygen, liquid hydrogen based architecture for our engines, for our reaction control system, and even how we generate power on the surface of the moon are resources that can be utilized and mined directly from the moon. That will form the basis to then fly cargo that will allow humanity a permanent presence on the moon.
Okay, when you land on an unprepared surface on the moon, no landing pad, there are bad things that can happen. First of all, the engine plume can accelerate particles on the surface. I'm talking things like gravel, okay, shrapnel at velocities of kilometers per second. That's dangerous stuff. The other thing that can happen is you can crunch your engine on the ground when you land. That happened on Apollo 15. Good thing is, in our design, with a separate descent element and then the precious stuff, the crew and the ascent engine on top, you're out of harm's way. It's safer. It's so much safer.
Our lander is designed to handle a fair degree of slope in the lunar surface it lands on, up to about 12 degrees.
The crew cabin is about 30 feet off of the surface of the moon. The radiator, the antenna, the solar arrays, those are lifted off of the surface. The astronauts can see out the window, they can see the horizon and use that for some navigation. The National Team's human landing system allows us to abort at any phase of the mission and at any time during a 6.5-day stay. Our solar arrays are fixed to our vehicle. We have engine out capability.
One advantage of having the hatch on the ascent element so far from the lunar surface is that it will help mitigate the dust issue. The dust is very sharp and it clings to things. It's also not good for the lungs. So any time you have for that dust to fall off is very helpful.
Personally, I'm most excited about the mission to land the first woman on the moon. I think that's going to inspire the next generation of students.
Having been part of the leadership at NASA for a long time, particularly during lean years, it was really exciting for me to hear that the national team has teamed with NASA and has hundreds of millions of dollars of task orders planned at all the NASA centers, including Marshall, utilizing the expertise that the agency has and the unique facilities that NASA has to bring.
It's a remarkable team, and certainly is one which the United States, as well as the participants, can be very proud.
When the crew of Apollo 17 left the moon and Eugene Cernan climbed up the ladder for the last time, his quote was, "We leave as we came, and hopefully as we shall return, in peace and with hope for all mankind." And I think the shall return is a part of there that's really motivated me ever since the beginning of my career in space exploration.
We have to use the resources of space. We must have a future for our grandchildren and their grandchildren. We were given a gift, this nearby body called the moon. And it's this generation's job to build that road to space so that the future generations can unleash their creativity. None of this is easy, all of it is hard. Big things start small.